Okay, on today's lesson, we're going to be looking at completing the square. Objectives are to understand how to complete the square, use completing the square to find roots, and use completing the square to make vertex form. Our vocabulary is complete the square, using the additive property to make a perfect square to find roots and or vertex form. General form, y equals ax squared plus bx plus c, and vertex form, y equals a times the difference of x and h squared plus k. We're going to start with exactly what is completing the square. So what I've got is I've got an expression x squared plus 8x. What we have here is a missing part of general form. And what we want is we want a general form that's going to give us a perfect square right here. Perfect squares are numbers that if we square root them, they give us a number that is easy to work with. They're not going to be radical expressions. Some examples would be 9. You square root 9, you get 3. 25. You square root 25, you get 5. So what we have here is we have x squared, which comes from x times x. And we've got this 8x here that we need to get from these two. Well, what we're looking for is, to complete a square, we want a number times itself. So what we want is a number that added to itself will give us 8. So the easiest way to figure this out is take this value and cut it in half. So we've got a plus 8. We need positive 4. This is going to give us 4x and 4x. And to complete our square, 4 times 4 gives us 16. So what we have to do is add 16 here. This can be done in a lot of different situations. The first situation we're going to use it for is finding roots. So I'm going to start with this problem on the left here. Y equals x squared minus 10x minus 11. If we want to find roots, we're going to put 0 in for y. Well, this general form is not a perfect square. So what we're going to do is we're going to get rid of the minus 11, add it to the other side, and then create a perfect square. Since I have a minus 10 here, what I do is I divide the negative 10 by 2, which gives me negative 5. If I square that, I'm going to get a positive 25. So all I have to do is add 25 right on here. The trick to remember is the additive property, which means if I add 25 to this side, I must also add it to this side. This then creates 36 equals, well, what we can do here is this right there is a perfect square. It comes from x minus 5 being squared. How do we know this? We can use our Punnett square. We wanted that 25 because we took negative 5 and squared it. So these have to be our negative 5s. Since that's x minus 5 times x minus 5, it can be rewritten as x minus 5 squared. So now what we can do is we can solve the rest of this by square rooting. Because we put the square root in, we have to split it into two problems. 6 equals x minus 5. And negative 6 equals x minus 5. we'd add 5 to both sides in both problems. And we have 11 equals x, and negative 1 equals x, which gives us our roots of 11, 0, and negative 1, 0. Okay? This version is not going to come out as nice and pretty as that one. This one's going to give us a radical expression for our roots. So I wanted you to see that. Again, we're going to put 0 in for y. We need to move the positive 1 because that's not going to help us in this situation. So we've got 1 equals x squared plus 6x. So all we do is we take our 6, cut it in half to get 3. This one's a positive 3. That's going to be important. Last one was negative 5. That's why we had x minus 5. This one's positive 3. That's going to give us a plus in our problem. We're going to square it to get a positive 9. So we're going to add 9 to both sides. It's going to give us 10 equals. We need to take this and turn it into our perfect square. So we're going to get x, because this was a positive 3, it's plus 3 squared. If we want to Punnett square or FOIL that out, we'll see we'll get x squared plus 6x plus 9. Then from here, we're into the same steps. Square root. Well, the square root of 10 does not come out perfect. I'm going to leave it as a radical expression in this situation. Square root of 10 equals x plus 3. Negative square root of 10 equals x plus 3, minus 3 on both sides. So we get square root of 10 minus 3 equals x. Not like terms, can't combine them. And negative square root of 10 minus 3 equals x. If we wanted to, we could type these into a calculator, come away with rounded answers. I'm going to leave them the way they are. So we've got a root of square root of 10 minus 3, comma 0, and negative square root of 10 minus 3, comma 0. So that is how we find the roots using completing the square. We can also find vertex form. I'm going to do this the same way, except because I want vertex form, I'm not going to change y into 0, but I'm still going to move my number across the other side. So I'm going to minus 5 on both sides. This is going to leave me with y minus 5 equals x squared plus 6x. In this one, we're still going to go through the same steps, except at the very end, when we would typically solve the problem, we're going to do a little bit of moving back to create our vertex form. Here we've got x squared plus 6x. We want to complete the square, so we're going to take our positive 6, cut it in half, get positive 3. We're going to square that and get a positive 9. I'm going to add 9 to both sides. So instead of y minus 5, I'm now going to have y plus 4 equals, well, I have this, I might as well turn it into my perfect square, which is x. We used a positive 3 to get our perfect square, so add 3 and square it. Now we have this set up. Well, to make this into vertex form, all we have left is one step. We've got this plus 4, subtract 4 on both sides. Since this is inside a square, it's actually going to just trail us. So we've got y equals x plus 3 squared minus 4, which now looks like vertex form. If you want to identify the vertex in this setup, we use our vertex knowledge. We've got a positive 3 here, meaning that it's going to be a negative 3 for a vertex. And we've got minus 4 here. That's going to stay a negative 4. And so we have vertex form and our vertex with it. Thank you. This has been Completing the Square. If there is anything that you didn't understand, you need to see again, please pause, rewind, and watch again. Thank you.